Hello and welcome back to App for You. In this particular video, we are going to discuss a new problem from trees, and basically we are focusing on binary search tree, right? And this is a very basic fundamental problem from binary search trees, wherein we have to check whether a tree is binary search tree or not, right? So before we begin, I think we should understand what is a binary search tree, right? So the problem statement here clearly says that given a binary tree, we need to check whether it is a BST or not. Now they have also strictly mentioned that we are considering that BSTs cannot contain duplicate nodes. Now, although they might have duplicate nodes, but as per this particular problem statement, they have put a constraint that just consider that BSTs are not having any duplicate nodes, right? They are not allowed to have duplicate nodes. This is what we need to consider. So right now, as per our assumption, we will assume that no duplicates values are allowed in a binary search tree, right? So what next? Now consider this particular example. If you look at into this example, you'll find out that there are three nodes, 1, 2 and 3, and it is basically forming a tree, right? Now the left subtree of a root, obviously this is a root node, so the left subtree of this root contains the key which is less than the root node's value, right? And the right subtree, basically this one, contains keys which are greater than the root node's value. Hence this tree is a binary search tree. So I hope you understood what is a binary search tree actually. So binary search trees are those trees in which, for any root you will consider, what happens is basically, so whatever node you consider, basically you will find out that its left child has basically smaller value and the right child has basically greater value. Alright, so let us now look into the another example. So if you just look into the another example, like example 2, you'll find out that this is basically a right skewed tree, right? So you will find out that whatever values are present to the right of 2, right, whatever values at any level, you will find out they are actually greater than 2, because our rule already says that, our protocol says that in a binary search tree the values to the right of the root should always be greater than that. Okay, normally it is greater than or equal to, but here they have said strictly that duplicates are not allowed. So basically we should consider it should be strictly greater than 2. So you can see at any points whatever values are present in the right of 2, because this is a subtree, isn't it? This is basically a right subtree of 2. So whatever values are present, they are basically greater than 2. But any point if you find out they are equal to 2, and we know that since our question already said that duplicates are not allowed, so we will assume that this is not a binary search tree. So you can see output is 0, which means it is not a binary search tree. So which node do you think created a problem? Definitely this node, because our problem statement clearly mentioned that we are considering that BST cannot contain duplicate nodes. But the moment we find out that any value is greater than any value is equal to 2, like right now just we found out that if my node is containing 2, then all the key values in the right subtree should be basically greater than 2, right? Should be greater than 2. But this point, this is fine, this is fine, this is fine, this is fine. This point it created a problem because it became equal to 2, and hence it is not a binary search tree. So I hope you got the intuition about a binary search tree, right? So one example I can give you, like suppose this tree 9, and on the right suppose you have 15, on the left suppose you have let me take 3. So on the left of 3 you will get 2, on the right of 3 you will get suppose 8, and left of 15 you will get suppose 12, and right you got 16. So if you look into this tree, this is basically a binary search tree. Why? You see, you consider this root node. Now see, at every point you will find out that the property of binary search tree is satisfied. Why? Because, now please understand this particular definition very carefully, because the code basically depends on this only. So if you consider this 9, this is the root node right now. So if you consider the entire tree, consider the entire tree, you'll find out that this is my root node, and whatever values are present to the left of it, means in the left subtree, they are basically less than 9, and whatever values are present to the right of 9, they are basically greater than 9. Okay, so the values in the right subtree should be greater than the parent node, and the values in the left subtree should be less than the parent node. Similarly, if you consider this subtree, now obviously in this subtree this is the node, so the values to the left of this node you will find out should be less than the parent node. Values to the right of this should be greater than the parent node. Greater than 3, less than 3. Similarly for this subtree, if this is the node, you will find out the values to the left of this node should be less than the parent node. The parent node is this, and the values in the right of this should be greater than the parent node, right? So having said that, I think now we are ready to write our code. So how do you think we can write our code? So basically you can see that we are asked to check if a tree is binary search tree or not given its root node. So what will we do first? First of all, what we will do is we will uh, consider two variables. First of all, integer mean and max. Alright, now what will be mean and what will be max, I'll be explaining you in the later stages. So mean is the minimum value possible, int mean, right? And max is basically the maximum value possible, int max. Why am I using it? I'll be explaining you. Now since we need to check if it is BST or not, so we are just calling the function check. We are going to pass the root node, and we are also going to pass the minimum value and the maximum value allowed. Done. So we will say that if check of this is true, then return true, else return false, right? Now means if this particular function, when I'm calling, if this function returns true, then it means, if it is true, then it means it is my binary search tree, else it is false, means it is not a binary search tree. So what is the function check? So we will be defining the function check here. So let us quickly define the function check. So function check will basically be a boolean type function, boolean check, and what will it receive is basically node star root, comma, integer mean, comma, integer max, right? Because these three parameters are being received as arguments. Anyway, so right now what we are doing is we receive the root node here, we receive two variables, mean and max. So first of all we will check that if root equal to null or not. If root is equal to null, it indicates definitely it is a binary search tree because it is an empty tree, right? Return true. Otherwise, what do you think will be a condition that it will no longer be a binary search tree? So if we find out that roots data is basically less than minimum, less than equal to minimum, I'll be explaining this, or roots data greater than equal to max, sorry, this is max, fine, then we will return false. Why do you think so? Now you see, considering this tree, now when I'm saying that, okay, when I'm what will I do is, now let us continue the code first, then I'll be explaining. So please remember that this is the condition that will make me conclude that it is no longer a binary search tree, because this is the point where the property of the binary search tree will be violated. How is it violating? I'll be explaining you. So if these conditions are satisfied, then just return false. Otherwise we will return the value returned by the left subtree and right subtree. So left subtree means check if the left subtree is a binary search tree. Now remember, the binary search tree property should be satisfied by every tree, every subtrees. The entire tree should be satisfying binary subtree. This subtree should also be satisfying binary search tree property. This subtree should be satisfying binary search tree property. This subtree should be satisfying binary search tree property. This also, isn't it? So all the subtrees here should be basically satisfying the binary search tree property. That is why what I am doing is, for a given parent node, given a root node, I will be checking if its left subtree and right subtree are satisfying binary search tree property or not. So check, since I want to check the left subtree is satisfying binary search tree or not, so I will be saying check root left. Done. So check root left. You are passing the address of the left node, means I am passing the address of this. Suppose I am in this node. This is my root node I received. I am passing the address of this node 3. Done. So I passed the root node of the left subtree. What do you think is the the minimum value allowed in the left subtree? So remember the question is minimum value allowed in left subtree. Definitely it can be anything, but it should not be greater than, it should not be less than the minimum value, because mean value is what? Int mean, isn't it? Int mean. So you can have any values less than this. 9 is there, so you can have 3, 2, 1, 0. Suppose you can also have some negative numbers, no problem. But the issue is you should not go beyond this limit. What is your limit? The limit is minimum, because whenever my code will detect that it has gone less than equal to minimum, then it will be an issue, right? So I am saying that in case of the left subtree, my concern is not about the minimum value, right? I am concerned about the maximum limit that is possible. So whenever I am calling the left subtree function, you can see here I will be passing the address of the left node, comma, the minimum value allowed. So min can be written, because this is what the minimum value is, isn't it? minimum. Integer mean, this is the smallest value possible in this integer. But in case of left subtree, whenever we talk about left subtree, focus on max limit. Why? Because what is the maximum values that you can have in the left subtree? Now the maximum value in the left subtree should not be greater than the roots value, isn't it? That is the max limit. So whenever we talk about the left subtree, we should focus on the max limit possible. So max limit should here basically be what? Root data, current roots data. For example, if I'm talking about if I'm at this root node, if this is my root node, and I'm checking if left subtree is binary search tree or not, then I should check what? That whatever nodes are present here should be basically less than the root node 9. That is why root data. I hope you got the point, right? And basically we are not concerned about the smallest value, right? Because whenever we are talking about the left subtree, we are more concerned because values can be smaller than this one, right? Values can be smaller, is fine, but remember the maximum limit allowed is less than the roots data. You cannot have any value in the left subtree which is greater than the root data. That is why we are checking here. If you find out in the left subtree that root data has become greater than or equal to max, any point greater than or equal to max, then it will return false. I hope you got the point. So this was for the left subtree. What about the right subtree? So we know that since it is a binary search tree, property should be satisfied, so both left subtree and right subtree should be returning true, isn't it? Check what? So root right, because I want to check if the right subtree is binary search tree or not. Now if you focus on the right subtree, so this is my right subtree, right? And this is my root node. If this is my root node and this is my right subtree, what do you focus on? You will be concerned that whatever values are present here should be greater than this. There should be no value which is less than this, which means you got the minimum limit. So whenever you are looking into right subtree, focus on minimum limit, right? Values can be greater than that. You can have maximum values, thousands, 1 lakh, whatever. But remember, whatever values are there should not be less than this root node in the right subtree. That is why in the right subtree we focus on the minimum limit. So in case of right subtree, what will be the minimum value? The minimum value possible should be basically what I am writing here is the minimum value is, this is my minimum limit, right? 9. So whatever value you pass should be greater than this. So minimum, sorry, not minimum, root data will be acting as the minimum, isn't it? This root data means this 9 will now act as the minimum limit, minimum value for this binary search tree, right? Minimum 9. But we know that if we find out that the value here at any point in the right subtree becomes less than or equal to min, even if you find that it is equal to this 9, then it will be an issue, right? Because you cannot have duplicate values. So that is why I'm saying root right, passing the right subtree, root data. Now this root data is basically acting as what? Minimum. You can see the second argument here is acting as the minimum value. So for the right subtree, this root data will act as the minimum value, which means that clearly that the values here should not be less than this minimum value. Now what is the maximum value allowed? Now you know that maximum value can be anything, but make sure you are within the limits. So max. And you know what is the value stored in max? Max has stored the integer max value, right? So you can have large values here, no problem, but remember that should be within the limits. And what is the limit? Int max, right? So that's all from this binary search tree code. And finally what we are going to do is we are going to return, so one more bracket is missing here, so let me write it. Yeah, yes, this has already done, it's fine. So this is what a binary search tree, checking for a binary search tree code will look like, right? Now if you want me to explain the working, I can explain you. So let me just quickly write out this particular example that I have considered. So I have considered 9, 3, 15, 12, 16, 2 and 8, right? So my concern is to check whether it is a binary search tree or not, right? So how do you check whether it is a binary search tree? Remember, I just passed out the root node first. So let me just use change the color of the ink. So what did I do is I passed out this root node initially. So root node was passed, and minimum value is the minimum limit possible and max is the maximum limit possible, no problem. This was called and my control moves to the function here, right? What did I do next? Next basically this was the root node received, means 9. Minimum was the minimum integer possible, maximum integer possible. Is root equal to null? No. So If it is null, then return true. Otherwise, go in this if statement. Is root data less than the or equal to the minimum value? No, because we know that suppose minimum is minus infinity. Actually, it is not minus infinity, the smallest value possible. Okay, depending on the size of the integer, and max is suppose plus infinity. So definitely this 9 here, root data is less than equal to minus infinity, is false, and root data is greater than equal to plus infinity is also false, right? So this will also not be executed. It will come here. What is it doing? It is doing a recursive call on the left subtree, which means just do a recursive call on the left subtree, and once you have returned from the left subtree, then you do a recursive call on the right subtree. So basically what I am doing is, right now I'll be doing a recursive call on the left subtree first. So again this is passed as a root node. Okay, so is this value, now when you are passing this, when you are considering the left subtree, now basically you are aware of the limits. What is the limit? When you are considering the left subtree, you know that the maximum value allowed in this is basically less than this root data. That is why you can see under the max, means this part, you can see root data, this is the max value allowed, right? Root data is the max value allowed, means you in a normal binary search tree, if duplicate was allowed, then definitely 9 should be allowed here. You cannot have any values which is less than 9. Okay, you cannot have any value, sorry, which is greater than 9, right? So the maximum permissible value here allowed is basically should be 1 less than 9, but I'm just passing here 9 to give me the maximum limit. So 9 basically is the limit, which means you cannot exceed 9, right? And what is the minimum value allowed in this left subtree? Now you know that minimum value can be anything, right? As far as it is less than 9, it is fine, but again there is a limit for minimum value, int min, right? That is why. So you can see that this node value, now again it will check root left min root data. So what will it check? It will check that is this root data less than equal to min, false, right? Because we know that the minimum value is int min. Is it less than is it greater than or equal to root max? So what is equal to max? Max is basically 9, isn't it? Because I have passed root data as 9. So is this node 3 greater than or equal to 9? No, false, which means it will not return false. What it will do? Again it will do a recursive call on the left subtree. Left subtree is what? 2. Now this time what will be the maximum limit of this left subtree? Again this 3, isn't it? Root data. You can clearly see. Okay. So you can see that what is the, now when I call again the left subtree, you can see this is a recursive call, nothing else. Initially I considered the entire tree, recursive call on the left subtree, then it considered this. Again recursive call on the left subtree, it considered this. When it is considering 2, it is passing the maximum limit allowed as root data, which is 3, right? And minimum, you know, can be the integer minimum, minus infinity, root left. So now what will it do? Recursive call, so it will check, is it null? No. Is root data less than equal to minimum? False. Or root data greater than equal to max? Is it greater than or equal to max? Max is what? The value that I passed here, root data, means 3. The false. So this will also not be executed. What it will do? Check root left on the left subtree. Left subtree is what? Null. So what will it return? True. So remember, true is returned by this subtree. Which subtree? This small subtree. True. Right subtree will also return true. Done. So what is actually happening is left subtree is returning true because it is null. Right subtree is returning true because it is null. And this entire subtree, this 2 only, will return true. Done. Now there will be a recursive call on the right subtree. On the right subtree, this right subtree. What is the root? Root is 3. So 3 basically has successfully done the execution on the left subtree. Now it is doing the execution on the right subtree. Done. So what is happening? So let me just make it more clear. This is 3, 2 and 8, right? So this is 3, 2 and 8. So 2 has already returned true. Now it is doing a recursive call on the right subtree. So when I do a recursive call on the right subtree, what will I pass? Root right means this pointer. What is the minimum value allowed here? The minimum value here should be greater than this 3, right? So this is the limit. So this is my passing. I am passing this as the root data, which means the minimum value. Remember, the second argument is minimum. So root data will act as a point of minimum, means you cannot have any value which is less than 3, right? So basically, and maximum value can be anything, isn't it? Remember, whenever we are considering our right subtree, so our focus should be on the minimum limit, because maximum can be anything, any large integer, but provided it should be within the range, isn't it? So same thing is happening here, right? So that's all. You can see again it will be checking, is root data 8 less than equal to minimum? So what is the minimum value you received? Minimum value received is 3, isn't it? Root data 3. So is it less than 3? No. or is this greater than equal to max, has it crossed the maximum limit? No. So this will not be executing. What will it do? It will come here again, it will do a recursive call on the right subtree. Recursive call on the right subtree is null. So basically left child will return true, right child will return true. So this overall true and true will return true. So this entire subtree returns true. So left child returns true, right child returns true. So you can see for this as the root node, return left subtree's value and right subtree's value. So this will return true. So remember the left subtree here of this node, which was 9 here, right? 9 returns true. Now finally for 9, if you consider 9 as a root node, for 9, considering 9 as a root node, the left subtree has already been checked for BST, and this is a BST. It is found that left subtree is a BST because it is satisfying the binary search tree. But remember, we should have the right subtree also as BST. So now it will do a recursive call on the right subtree, which means it will consider this first. When it is considering this, now since I am considering right subtree, you should be aware about the minimum limit, isn't it? Because right subtree determines the minimum limit first. So what is the minimum limit? Root data. You can see root data is acting as the minimum value, isn't it? Because second argument is minimum value, which means your value should be at least greater than equal to 9. But here it should be greater than 9, not equal to 9, right? That we are checking here, no problem. So we are passing 15, now we are passing 15, we are checking is 15 less than equal to minimum value. What is the minimum value limit? They have said that is the root data, 9. Is it less than equal to 9? False. Or is it greater than equal to maximum limit? Maximum limit is plus infinity, suppose. No, this will not be executed. It will come here. Again, do a recursive call on the left subtree. So left subtree is 12. Now for 12 it will pass what? Now since it is a left subtree, we know in left subtree we are determining the maximum limit. We are more concerned about the maximum limit. So what is the maximum value allowed here? Should be the less than the root data. That is why in case of left subtree, whenever we are doing a recursive call on the left subtree, you can see the roots data, the parent root data is acting as the maximum limit. So now we are checking is 12 less than equal to minimum. 12 less than equal to minimum. What is the minimum value it received? Whenever I did a recursive call on the left subtree, the minimum value was what? Min only. Int min. Is it less than minus infinity? No. Is this 12 greater than equal to max? What is the max limit? 15. Isn't it? Remember when I did a recursive call on the left subtree, what was passed? The roots left, means this was passed, minimum value was passed, and roots data, which means 15 was passed. So 15 is acting as the max limit. Is it less than equal to max? Is it greater than equal to max? False. So again what will it do? False. So this was also false, this was also false. This will not be returned. Again it will do a recursive call on the left subtree. Left subtree is null, so it will return true. Right subtree is null, it will return true. This entire subtree will return true because true and true is true. So you consider 15 as the root node. Remember its left subtree is returning true. So again it will do a recursive call on the right subtree. If you are passing on the right subtree, what will you do? You will pass the address of this node, comma, the minimum value will be, this root node will act as the minimum value, isn't it? Because roots data is acting as the minimum value. So minimum will be equal to 15, maximum is the maximum limit allowed. So now you are checking what? Is it a binary search tree? So for that I am checking if it is less than equal to minimum. What is the minimum value? 15. So is it less than equal to 15? No. So false. Or is this value greater than equal to plus infinity or max limit allowed? I am saying plus infinity. Actually it is the maximum integer value allowed. Okay. So this is also false. Definitely this will not be executed. Come here, do a recursive call on the left subtree and the right subtree. Left subtree is null, returning true, because if it is null, returns true. Right subtree is null, returns true. This entire subtree will return true. So considering 15 as the node, its left subtree and right subtree has returned true. So basically again this will also be a binary search tree. It is also returning true. So now considering 9 as the root node, the left subtree has returned true, right subtree has returned true. So definitely true and true should be returning what? True. I hope you got the point. So this is how the problem is actually working. So remember what was the point of concern? The point of concern was that what should be the maximum limit. So the point of interest is basically when we are considering a left subtree, whenever you are doing a recursive call on the left subtree, remember this part. Whenever you are doing a recursive call on the left subtree, okay, what should be under the minimum? This is minimum and this is maximum. What is the minimum value allowed? So in the left subtree, the minimum value allowed is anything, but you can have the minimum value allowed is the smallest integer possible, isn't it? This is the minimum value allowed. And in case of left subtree, because this is for left subtree, what is the maximum value allowed? The maximum value allowed is basically less than the roots data, the parent's data, right? The maximum value allowed in the left subtree should be less than its parent, right? And in case of right subtree, we are focused about what? The minimum value allowed. Right subtree focus on minimum limit. So right subtree, this is minimum, this is maximum. So in right subtree we know that the values can be anything. The maximum limit allowed is the maximum value possible, but the minimum value should be at least greater than the roots data. That is why roots data is passed here as minimum, right? So I hope you got the intuition. Now let us quickly compile and run the code, assuming we are not doing any silly mistakes, right? So you can see the problem has been solved successfully and submitted, right? So I am not getting any score because I have already executed this code. So that's all from this particular video. I hope this video was helpful and intuitive. In case of any doubt, please feel free to put it out in the comment section, and just like, share and subscribe. Thank you.